And now we're back. So we defined the likelihood function for logistic regression. We computed its derivative. We talked about a simple gradient ascent algorithm for finding the best parameters. And for those who went through that full kind of slow mathematical derivation, you saw where that gradient came from, but that was totally optional. We can go back and summarize where we are now. So in our learning problem, we start with some training data. We threw this some feature extractor that gets us h of x, and we use a logistic regression model that says the probability that it's a positive review is 1 over 1 plus e to the minus w transpose h. And then we define a quality metric, which was the likelihood function, and we use gradient ascent to optimize it to get w hat. And the gradient ascent algorithm is pretty simple and pretty intuitive. Now you're able to define what the quality metric is for logistic regression. You can interpret that likelihood function as being kind of the probability that you get the training data right, and you want to maximize that. We talked about the gradient ascent algorithm that does it with really simple updates, and we had this optional section where we derived the gradient ascent algorithm from scratch. Next, next module, we're going to take this one step further and explore the idea of regularization and overfitting in logistic regression, which is a really important thing in practice. So that's where we're going to go in the next module. But now you're ready, even at this point, to implement your own logistic regression algorithm from scratch, which is super exciting.